All right, Bert, take the stage.
Okay, thank you. So, welcome to the Axon Server training. Today, we're going to talk about the messaging platform and event store that you will use within an Axon framework or typical CQRS and event sourcing based application, and how Axon Server helps with that. Maybe just a bit about how this works for the training. First of all, we have 2 online sessions today and tomorrow. It says here 2 hours, but we have reserved 2.5, and especially tomorrow we'll actually use all of that thanks to a lot of demoing. But I'll start tomorrow with a small recap of today, just to make sure that we have everything back again. Then there will be time for questions and answers. Actually, given the number of people in the training, maybe it's best if you have a question to use the button to raise your hand, and then I'll find an appropriate spot in the story to stop and react, or ask you to pose the question and react. So you should have received an invitation to join the Slack workspace of Axonic, and that gives you access to the Axon Server training channel that is made for this month. Please use that also, and of course that allows you to post some longer stories if you want to give a bit of background to your question, and there will be other people also monitoring the channel and answering. But be advised, we are mainly based in European time zones, so most responses will be during European business hours. Then there are a lot of other sources, locations where you can go for information and study. The developer portal, of course, is developer.axonic.io. There you can find a lot of information, articles, download links, and other references. We have the forums on Discuss. Then there is the Axonic Academy, which is going to be continually added to. Currently, we have there mainly articles about generic CQRS and event sourcing trainings, and about using the Axon framework. But there will also be trainings posted there about Axon Server. Then, of course, there are several GitHub repositories. The list for that starts, of course, at the developer portal, so check there if you want to take a look. Lots of example applications, but also reference materials that I'll refer to during the presentation today. And then, of course, there is the reference guide. Then during the training, everybody is already muted, so please keep that. If you want, you can switch on the camera to show yourself. If you shortly press and hold the space bar, then that will unmute you to be able to ask questions. And as soon as you release the space bar, you will be back on mute. Or if you just hit it shortly, it switches between mute and unmute. But the most important thing is use that option, use the option to raise a hand, or the quick chat box, of course, and ask questions, and of course also in the Slack channel. Note, we also use the Slack channel to provide you with a trial license for Axon Server Enterprise Edition, which is valid for 2.5 weeks. If you want some more time, then no doubt Ted will be able to help you. And we also will post their links to the recordings of this training, and you will get a PDF copy of the slides of today and tomorrow. So then I can skip this one because we already made that round. Let's take a small look at the agenda for today. We're going to look at the messaging platform. We're going to look at the event store. Then, of course, we're going to talk about how to connect an application to Axon Server. And we're going to talk about Axon Server plugins. Then tomorrow, we're going to take some more enterprise features, clustering with Axon Server Enterprise Edition. We're going to talk about security, both for Axon Server Standard Edition and Enterprise Edition. And we're going to talk about observability, how to find out what is happening in your cluster. So let's start. And maybe you've already come across this phrase, dump pipes and smart endpoints. It was introduced by Martin Fowler in the context of microservices architectures, and what he was aiming at was the idea that we should try to put as little intelligence as possible in whatever we're using as our messaging platform. The reason for this being that those kind of platforms, when they allow a lot of logic to be put in there, they end up to become a platform for business logic, which means that they're going to blur the lines of where you have deployed parts of your application. So if possible, you should try to keep your communication pipes as dumb as possible and put all the logic in the endpoints. But if we're going to start with messaging, then of course, nowadays, that gives us a small problem, or small, it might even be a large problem, and that is that we rarely are talking about one single application anymore. Generally, what you'll see is that we have a collection of applications, call them apps, call them microservices, and they need to communicate with each other. And even that is not everything, because if we have those small applications, then we can pick up load a lot better, and also availability a lot better by making multiple copies of many of those components. So the problem then becomes, if I'm going to send a message from one component to another component, I need to know how many of these applications there are, where they are located, and which is the one that my message needs to go to. So we need to create something that is called location awareness. To send a message, we need to find an address for that message, which means that we need to find within those applications the one that I need to talk to, and within that application, the one component that my message needs to end up. This is what is generally called discovery. But the problem, of course, is if you use discovery for every exchange, then generally what you'll end up with is lots of boilerplate code. So the alternative would, of course, be to use some kind of component or framework or library that will add that code to your application as transparent as possible. And that gives you the opposite of location awareness, which is location transparency. So the best approach from the perspective of the application is to have discovery as part of delivery. So all we need to do is just hand off that message to whichever component will provide our messaging service, and that component will do both discovery and delivery. In the context of today's training, of course, we're talking about the Axon framework and Axon Server. Now, for message routing, we also need to take into consideration what kind of message we're going to send, because not all messages are the same, and if they have a different purpose, that will bring different routing requirements. So let's first take a small look at the different routing patterns that are involved that we generally see here. In this case, we're going to talk about synchronous, asynchronous, streaming messages, and the fan-in and fan-out patterns as examples. Let's start with synchronous message exchange. For this, the sender hands off a message to the messaging component and then waits. The messaging component transports it to the handler for that message. The handler processes that message, produces a result, and hands that result back to the messaging component. The messaging component then sends that message back. We can optionally process that reply and then continue. For an asynchronous message exchange, we start the same way by handing off the message to the messaging component. However, we're not going to pause. We're now going to continue with whatever next activity we need to do. The messaging component then transports that to the handler, and the handler processes that message, but it doesn't send back a message as a reply because there's nobody waiting for it. This means that it's often referred to as shoot and forget. However, this is not often what you want. But there is a bigger problem. And the bigger problem is that the sender only knows the transport has received the message, because the sender was not waiting, not even for a confirmation on the other side that the message was received. We don't really know. This may sound a bit like, okay, then you just need to buy a different component in the middle, but I can assure you, I worked for a large company that was using IBM MQ series messaging solutions. And yes, we had messages getting lost between sender and receiver. So this is something that can happen. And the only thing you really know is that your transport solution has received the message. If you want to know whether or not the handler actually receives it, you need to still do some kind of synchronization. So you get something that is then referred to as asynchronous request reply. Of course, it is still a synchronous exchange because we are waiting in some way for a confirmation that the message has been arrived or processed, or might even wait for an asynchronous reply to be sent back. The streaming option works as followed. We now send a message, but we keep the connection between the sender and receiver alive, so to speak, and the sender can then send additional messages. The receiver will continuously wait or be ready for more messages to come. Of course, this is not ideal, because that implies that the receiver needs to continuously check whether or not there are messages. So what we do nowadays is use the reactive approach, where we can push the messages to the other side, and we have support on the receiving side to make sure that the processing of that message is picked up immediately as soon as it comes in. Fan in and fan out, of course, well-known patterns. With fan in, we have messages coming in from several senders going to the same receiver, and fan out the other way around. We have one message that is going to be sent to several receivers. Well-known example of this, of course, is publish subscribe using fan out. And another one in the context of the Axon framework is, of course, the scatter-gather queries. With scatter-gather, we start with fan out and then use a time-controlled version of fan in, where we gather all the answers coming in within a certain time limit and process those as a combined result. A nice example, by the way, which is not an Axon framework example, but nevertheless a good scatter-gather example, is, of course, the booking site Trivago, where you can say you want a price for a certain hotel, and you see visually in front of you how the list of prices is adjusted while new answers come in. To apply these messaging patterns now to the Axon framework, we're going to use this example architecture for the application. We have here on the left the UI. You might also have something like a REST API or some other kind of API, such as gRPC. We have command handling components, we have event handling components, and we have query handling components. So we need now to look at how to send those messages to these components. So we're going to look at these areas. With the Axon framework, we have three types of messages. First of all, when something needs to be done, we have a command. When we want to report that something has happened, we send an event. And when we want to know something, we send a query. Each of these different types of messages requires different routing patterns. To start with commands, when we send a command, what we're trying to say is that we have an intent to change something in our system that is intentionally called like this, because the handler will be able to validate if that change is actually allowed. The client will send this to our messaging solution. The messaging solution then selects an appropriate handler and delivers the command to that handler. Next, the handler will validate this command. And this, of course, means that we have need for a synchronous exchange, because the sender needs to know whether or not the command was actually accepted. The reply is then sent back, and the reply in the case of Java, of course, could be an exception, which is the usual way of saying that the command was rejected, and then the exception will contain the information about why this was the case. However, on the handler side, what we often see is that the actual Java method doing this is a void method. This means that the client will not expect a actual data object to be sent back, but it will wait because it needs to know whether the command was accepted or not. You could have something like a real message, and generally what is most often used if you use a reply is that you simply return the ID. For example, if the command created a new aggregate, and you send back the ID of the aggregate that was generated. To deliver this command, we want to make sure that only a single handler gets that command. However, we already said that we have a modern environment, which means that there might be no handler currently available. That is not necessarily a fatal error, because it could be something as simple as we have a Kubernetes cluster where the application with the handler was being migrated from one Kubernetes worker node to another and was just temporarily not available. We might have networking problems. There might be other reasons. So the no handler for command exception, which is used on the Java side, is actually a transient exception. And then on the sender side, you can use a retry policy to make sure that you retry any transient exception. The handler, of course, if it receives a command for a modification or a deletion of an aggregate, first needs to ensure that it has a valid copy of the current state of that aggregate. So if it's not cached, it needs to rehydrate this. This means that there is a cost associated with not having it. That means that whatever solution we use to deliver the command should try to make sure that the same handler for the same aggregate is being reused. For this, we can use something that is called consistent hashing to select that handler, and that hashing is used based on a routing key, which is often the aggregate ID, but it does not need to be. Then the next type of message we need to look at is, of course, event messaging. Now, event messaging, an event message specifies that something has happened. In the case of an event about a change on an aggregate, this means the command has been validated, the change has resulted then in an event which describes that change. So we want to process this event on all handlers. None of the handlers need to actually send back a reply. So what we're going to use is an asynchronous publish subscribe. However, event handlers may want to replay old events. For example, if I have a handler in an application that has been freshly started, and actually that is a stateless application, then to find out what the current state is of that aggregate, it needs to start with replaying all events that are relevant. This means that we must have something to store those events. So all events in an Axon Framework application are generally stored. On the handling side, we now can react to those events by doing something like updating a view model with the changed state of aggregates. It might start or end an active process instance, what used to be called a saga. We could transition to a different state in a process instance. We could send other messages as a response to that event. So to deliver this event, we want to make sure that they are delivered to all handlers for that type. And we have to be careful here because not all handlers may be available. There might be a combined effort to build a large view model. In this case, we might want to have a group of event handlers distributing the processing load for this. We might want to start by replaying older events or from a specific time, or we might want to do a replay for a specific aggregate. So what in the Axon framework is done is the introduction of an event processor between the messaging solution and the actual handler. This event processor will then do the actual delivery to the handlers. And in the case you have, for example, multiple handlers building a shared view model, then this event processor can distribute the load across those handlers. Sorry. So we have event handlers and event processors. They are provided, and what Axon Framework does is provide an event bus and an event store. The event bus is used by the subscribing event processors. The events are delivered as they come in, and there is no replay support for these events. So if you're using a subscribing event processor, it will not be able to do replays. For the event store, there we have streaming event processors. These, again, the events are delivered as they come in, but now we have added replay support because on the other side, we have that event store with a copy of all the older events. The last type of messages, queries, there we have several different types of queries. Let's start with regular queries. For a regular query, the story is pretty much comparable to what happens with a command. A query is sent to the messaging solution, which selects an appropriate handler. The handler will process it and send back a reply with the answer that we're interested in, and this is then sent back to the client. The second type of query is the scatter-gather query. In this case, the command is sent to the messaging solution, which then distributes it to all handlers. And then the answers are gathered and sent through to the client, which can gather them into the wanted reply using a timeout. Then we have subscription queries. Subscription queries have two phases. In the first phase, it works just like a regular query. So we see the query going out to the handler and a reply going back. But now the connection is kept open and turned in the other direction. And any matching handler can provide updates to the client. And this month, we have released Axon Server 4.6.0. The Axon Framework 4.6.0 is expected in September. And with that, we have introduced a fourth type. And that has to do with the situation where you are worrying whether you need to choose a subscription query or a regular query when you actually have a regular query with a collection of results. The problem there is that if you use a regular query and send that on to the handler, but now we have the handler gathering all the results and building a collection, that we have a handler that might be quite busy for quite a long while. And now we need to wait until all the answers are there before we get our result. So what we have introduced is support for streaming queries. This makes use, of course, of the reactive approach where we can have a flux for the messages. Now, when we send the question out to the handler does not need to first cache all the answers. It can send back all the individual answers as soon as they come in. And this, of course, looks a lot like a subscription query, but it uses a different API. What happens is that the framework will recognize that there is a list or a collection of response types, and then instead use a publisher for those response types. So to wrap up the messaging support with the Axon framework, to send a message, we need to determine what routing is needed for this message. We want to discover who will be the actual handler for that message, and then do the delivery. With location awareness, we can solve the discovery, but actually we want that to be transparent to the sender. So generally what we say is that the Axon framework with Axon Server will provide location transparency. For the three different messages, we have the commands routed to a single handler, and there will be a confirmation or result message going back. And we want to use something like consistent hashing to make sure that if we have multiple commands concerning the same aggregate, that they will, if possible, end up with the same handler. For events, those will be sent to all logical handlers using the event processors. there are no results expected, and the event processors can influence the actual timing and ordering of those events to the delivery of those events to the handlers. Last, we have queries. With queries, not mentioned yet, but we'll get back to that later. We want to be able to do things like load balancing across the different query handlers. We are going to get a result. That result actually is what it's all about. And we want to have support for things like scatter-gather patterns and streaming. But I hope that this small overview also helps you to understand why we say that events and messages are definitely not the same thing. So if you have within your infrastructure a solution which is targeting event handling, then do remember that that is not a generic messaging solution, because there are still routing problems that need to be solved. So let's see how we can solve those messaging requirements. For the Axon framework, what we need is something that is called a message bus. This message bus is one single component here sitting between our client and a collection of handlers. The bus will take care of doing the actual delivery, and because we only have a single message bus that we need to take into account, this is going to enable location transparency for the client. It no longer needs to worry about which of these handlers is going to do the actual handling. Of course, if we have a single application, then we can use a local implementation, which in this case is the pure Axon framework. And if we have multiple applications working together, then we need a distributed application, and this is where Axon Server comes in. However, we do have an alternative with the Axon framework, and that is the Axon framework with some extensions. This is, of course, fully supported, but in our opinion, Axon Server is the better solution. So let's start with looking at those extensions and how they solve the problem. For distributing commands on the API side, what we have is a command router, which will do the discovery. Then we have the command bus connector that lets us hand over the command, and this is all hidden behind the command bus or the command gateway, but these two will take care of discovery and delivery. Then on the local side, of course, it might be that actually the handler is in the local application, and then we can use a local command bus. This is also used if we're connected to some distributed command bus and a command from a different component comes in. On the implementation side, we have two extensions available. The first one is using JGroups, and the other one is using Spring Cloud, where Spring Cloud has separate components for the discovery and for the actual delivery, and the delivery there is done using HTTP. On the event side, we have for the API, as discussed already, to start with an event bus and an event processor, and in this case that is the subscribing event processor. For this we have on the distributed side the AMQP extension, which allows us to do messaging with AMQP compliant messaging solutions. And we have the Kafka extension if you want to use Kafka for delivery of your events. Then the second form, of course, that we need to look at are the stored events. And here we have an event store, and again, the event processors. In this case, there are two. the tracking event processor and the pooled streaming event processor. And nowadays, the pooled streaming event processor is the default. On the implementation side, we have, of course, a shared data source. So, for example, a relational database or a NoSQL database. And there is the Kafka extension. In case you are surprised, then I won't disappoint you. We think also that is a rather unusual thing to try and do with Kafka, but since messages in Kafka can be persisted for a certain configurable time, you could use that as an event store. However, we do have some problems with that. We'll get back to that later. Last, we have to look at queries, and here we have only the local implementation, the query bus, and the reason for that is that actually nobody really has ever been looking at a solution for query an implementation for distributed queries, because that was mostly done with REST APIs or something like the query language. So for that, we don't have an extension available. Now, this, of course, gives us a quite complex situation because we have several extensions that we need to do, and we're going to look at that and how we can simplify that into Axon Server. So let's start with one application. In this case, Axon Framework is enough. We can just have it in there and it will know all the handlers and be able to do all the delivery. But this is, of course, nowadays no longer the case. We are more likely to have multiple applications. Each of them will have their own instance of the Axon framework. And now we need to do something to get those messages from one side to the other. So let's start with an event store. We could use something like MySQL. Then, of course, we need a solution for the commands. So we're going to use the Netflix library to do the discovery of components, and then use REST with the Spring libraries for the actual delivery. Then, of course, we also need to look at events. So we're going to use RabbitMQ for our delivery of events, and we'll have to set up a queue for every endpoint. And that gives us quite a lot of components that we need to take care of. Then, of course, our application is not static. It's continuously being evolved, refactored, developed, and we could get an extra component in here. And now this component needs to be added also to our picture. So the problem we have here is that with this picture, we now need to select, configure, build, and maintain separate solutions. Yes, the Axon framework will solve our problems within each of our applications, but between them, we still need to get all the solutions for command distribution, event distribution, query, event storage, and query distribution. And if we have a single team needing to take care of all of this, then that is not developer friendly. And we tend to spend more time than we'd like with actually managing what is happening in here. And we haven't even touched on security and observability. So let's make this a bit simpler, going back to this picture. And now in the middle, we're going to put Axon Server. Just one component. It will do both the messaging and the event store. And if we have an extra component that we need to add, all it needs is a single connection to Axon Server, and everything will work. So with this, have we delivered on that goal of using dumb pipes and smart endpoints? On the dumb side of the spectrum, what we see there is the simple message broker. It's very fast, very reliable, but it's not going to do any routing, no transformations. So the problem is then we need some kind of a boilerplate code or support in the framework to make sure that the discovery and delivery is taken care of. So the message broker here is on the left side of the spectrum. Then we have on the right side, of course, something like an enterprise service bus. And it has lots of options for routing, for message transformations, even things like service composition. And of course, it has so much options that actually it becomes a development platform for complex interconnections. And I don't know if you're like me, but if you've worked in an environment where these components are used, the problem is you'll end up with a component that is often positioned within the organization as an infrastructure component, but it's still a development platform where you're going to put business logic. So it's going to blur the lines of ownership and blur the lines of what you need to do when you deploy new versions of your applications. So this is the problem that we wanted to prevent by not using smart pipes. Let's put the ESB over to the right. And what we see with Axon Server is that Axon Server knows about commands, events, and queries, and makes sure that each of them get their required routing options. However, it's not looking at the content of the messages. So there won't be business knowledge in the middleware layer if we don't want it. And that means we say Axon Server has just enough intelligence, so it's on the leftish side of this spectrum. How do we implement this? So we need to find in basis something to build this on. We want a flexible and efficient solution. And what we have selected for Axon Server is the gRPC protocol. It's a public protocol. It was developed by Google. It uses a language called protobuf to describe the messages. It's binary efficient, which is a great improvement over things like XML and even JSON. It's based on HTTP2, so it can use existing infrastructure for load balancing or for other gateway functions. And also because it's based on HTTP2, that means gRPC can use things like multiplexing and bidirectional communication channels. The way the protobuf language is made allows us to make messages that are binary compatible forward and backward. And this is something that we do also with Axon Server. So if you get a new version of Axon Server, that new version will be able to talk with old version applications with the previous version of the framework with the Axon Server connector. And also, if you update the Axon framework and Axon Server connector to a newer version than Axon Server itself, then also it will still be able to communicate well. gRPC is well documented and very important, it's language agnostic. So yes, we have done our own experiments also with JavaScript, and we actually have a customer in, I think in Australia it was, that built their own JavaScript-based layer that used the protobuf files, which are, by the way, public, and they built their own connector for JavaScript to Axon Server. There is also a partner working on a .NET implementation of the Axon Server connector, And there's even talk about having a look at a Python implementation. So this is all possible. The protobuf specifications for the messages are all published and publicly available. And if you want, you can use that. So given then that Axon Server is going to be our choice, let's see if we have some routing issues left that we discussed earlier. For commands, we want to take a look at consistent hashing. For events, we want to see if we can further optimize event delivery. And for queries, we want to see if we can do something with load balancing. So let's start with consistent hashing. The way Axon Server does this is by placing all handlers on something what in mathematics is called a ring structure. Here we have such a ring with addresses ranging from 0 to 255, written here in hexadecimal. And on this ring, we can place our handlers. Say we have 2 handlers and we put them here at the top and the bottom. Then, given our message with its routing key, we compute a consistent hash for that routing key. And let's say this ends up on D2. Then what we do is we pick the first handler clockwise, which in this case is B. This can be made more efficient by putting multiple copies of the same handler on the ring. About that JavaScript connector, I know that the code that we made is available, and I'll make a note of that to ask the developer internally who worked on that. About the customer, that is something we need to check with that customer if they want to make that available. That is, of course, not under our control. So let's continue. Event delivery optimizations that we can still do. What Axon Server does for events is that it starts by delivering all events to all apps that have event handlers. Then the Axon Server connector in that app can report back to Axon Server that certain events are undeliverable, for example, because it doesn't have a handler for that specific event type. And then Axon Server will proactively filter out undeliverable events. On the query side, we wanted to look at the optimization of using load balancing. Axon Server uses by default something which is, of course, simply round-robin scheduling, but Axon Server Enterprise Edition and clusters built with that will register the handler performance and use that to give better performing handlers more spots on the cycle. For subscription queries, what happens is that the initial response is routed just like regular queries. So for the initial response, it uses the same approach to use the load balancing, and then updates are streamed from any matching handler. So those are no longer dependent on the load balancing. Then let's take a look at the event store. Unless there are more questions about the messaging, of course. If not, then let's continue. So we want an event store to store our single source of truth. An event store will store all published events. And these events can then be retrieved both by consumers as well as the publishing component itself. This may sound unexpected if you haven't looked at that before. And let me illustrate that with a small example. Say I have a service A here on the left, and it manages some aggregate with its state stored in a database. And we have sent events about all the changes on that state, which are stored here in the middle in the event store. Now, if we make a new change, that change is again stored here in the database, and then a new event is appended to our event store. Then the service B on the right side, when it starts up, can first start by replaying all events in the event store, and from that moment on, it will receive any copy of new events after that. This, of course, is what we call event streaming. But what you generally see is that what service B is doing is using those events to build again the state of those aggregates. It might do it in a view model, so it might collect the states of all aggregates of a certain type, or it might build specific models that are optimized to answer a certain query. But if you do that, then actually what is happening is that you have all the events in the middle here that could produce the same result as getting the current state of that aggregate from its database. So we could remove that database and let the service on the left also use a replay to build the current state of that aggregate if it's not available locally cached. And this is what we call event sourcing. So event sourcing architectures are a subset of event-driven architectures in which events are at the heart of the persistence architecture of our application. And in effect, the event store is a hard requirement for being able to use event sourcing. So if we don't have a good event store, we cannot do event sourcing. Now, within our application, where we are currently looking here, of course, is in the top right. How can we implement such an event store? So let's take a look at what we need to support for this. And there we have on the right, and as in the writing, appending side of our API, we need to be able to efficiently append events. This means that we want as efficiently as possible to only add new events to our store. There's no need to delete, there's no need to update. But of course, we do need to validate the sequence. So we have to be careful and make sure that we're storing the events in the correct order. Then on the other side, the read side, we want, of course, to be able to do a full sequential read, as well as being able to efficiently read only the events that are associated with a specific aggregate. So to do that, let's take a look, and we'll use those requirements, give them a bit more detail. On the read side, what we want to do is stream events per aggregate, be able to stream them from a certain point in time. We want to efficiently be able to push recent events, so keep open the connection and use some form of efficient streaming. We want to ensure that events are read back in write order. And we, of course, want to make sure that we only read events that have been committed. This is not something we've discussed already, but it's possible to have multiple events within one transaction. We're not going to go into the details of that here in this training because we're focusing on the event store and Axon Server. But take a look at one of our trainings, for example, on the Academy, on the Axon framework, if you want to know more about this. Then, of course, if possible, we want this to be optimized for recent events, and we want to be able also to do ad hoc querying of our event store. On the right side, when we append events, we want to validate the sequence numbering, not just the global sequence number, but also per aggregate. We want to be able to have those transactions with multiple events at once. We want to make sure that our events are committed, protected against change or loss, and we want a constant performance as a function of storage size, because with an event store, since we're only adding events, it will grow large. And that means that we want to make sure that even if our event store becomes big, we have best possible performance. The solutions we're going to look at, we're going, of course, going to take a look at relational databases. We're going to look at MongoDB as an example of a NoSQL database. We're going to look at Kafka and, of course, Axon Server, but we're going to start with the other ones. Let's start with MongoDB. Sorry, a question. Is there a way to handle, maintain, or the order of the events published? Since you are publishing the events, then that means, I would say, that you are in control of the order in which the events are published. Is that not what you mean? Can you give a bit more background to your question, please, Asmina? And you're on mute. If you don't want to go into that now, at the handler end. I think maybe this is something that we need to take offline, but generally, because you are writing the code in the handler where you are ordering yourself how you publish those events, that means that you thereby ensure the ordering of those events as they are published. You mean that you can reorder them or ensure the correct order them by the handler? That is, well, first of all, that's the thing that the event store needs to guarantee, which is why we put it in our requirements. And the handler, so the event store needs to ensure that the events are stored in correct order, and also that they are replayed in the correct order. Then, of course, if you do have a processor, an event processor that then distributes the work across multiple handlers, it might be that you're not actually doing that, but that is something on the handler end that you need to be, you need to work out that this is only used if the handler actually is able to take care of that correctly. If you want to talk more about that, please post a message in Slack and we'll find people who can help you further with that. You might also want to show us examples of the code and we can give you examples. Okay, then let's continue with MongoDB. MongoDB, of course, is a very popular solution. It gives you great scalability, and it can use sharding for storing the data in multiple instances of MongoDB. And you also have a very good querying method on data stored in MongoDB. But we need to take a look at how events are stored there, because actually MongoDB is not a generic database, it's a document store. We could say every single event is a single document in MongoDB. Now, if we send multiple events to our MongoDB event store, they might end up on different servers. And with that, I mean MongoDB servers. That means that we no longer can guarantee the order in which they are stored, and certainly not guarantee that, for example, we always read the first one after the second one, if they are stored in that order, because it might be that this MongoDB instance already has it stored or doesn't have it stored yet, while this one already has. If at the same time we're running a query or running a replay, that could result in a situation where we get this event, but not yet this event. Worse, if we have something like a transaction of multiple events, then we get, of course, the problem with our ACID requirements, because we only want to have all events when they are committed at the same time. So this is going to be a problem. MongoDB does have extensions that support transactionality and transactions with multiple documents, but it's not something that is efficient, and we do need to make sure that we're going to put something on top of MongoDB to provide the sequencing of events if they end up on different MongoDB instances. The alternative, of course, would be that we're going to put multiple events into a single document, which will help us with the transaction, but now we have a problem that we don't know in advance where our event is. Is it stored singly? Is it stored somewhere in a document? And we have to be very careful that the events that are combined into a single document do not have gaps in between them. So MongoDB, although it's very scalable and gives us possibilities for doing analysis and querying on those events stored in it, it has some issues with doing document transactions, and also when we're going to stream those events, we need to add something to make sure that we get them in the correct order and we only get committed events. And of course, we still don't have that global sequence number. That is not something that we can let MongoDB do, so we need to add that and put that on top. Now we'll accept that there is a transaction extension, but still we don't get a good match for our requirements. Another alternative would be, for example, to use Kafka. Kafka is, of course, very popular, and because Kafka allows you to specify how long messages need to be persisted within Kafka, that means you could use Kafka also as an event store. So on the pro side, it's messaging focused, that is what it's good at, and it's extremely scalable. However, the problem starts when you have multiple aggregates with multiple events per aggregate. Now, here we have an example where we have the letters showing standing for aggregate IDs, and then the numbers for the sequence number within that aggregate. And suppose we want to replay the events only for aggregate B. This means we have to go through the entire event store and filter all events to be able to find only those that are for aggregate B. That is not efficient. The alternative, of course, would be to use something like topics. We could use a separate topic for each aggregate, but then we have to take into consideration that topics, which are logical and might span multiple nodes, are subdivided into partitions, and then partitions again subdivided into segments, where each partition has an associated directory and each segment has a log and index file. And this is something that does not scale into millions of aggregates. So only if we have an application that has only a few actual instances of aggregates might this work. Otherwise, we're going to run into a problem. So even though Kafka is messaging focused and very scalable in the total number of events, it's not scalable in the total number of aggregates. And again, we get a solution that is not a good fit for our requirements. Then, of course, the popular solution, especially if you're working for a larger organization, then you already have standardized on a relational database, or you might be in the cloud and want to use only managed cloud solutions, then you are going to use a managed SQL solution. This, of course, will give you well-established technology, and of course, anything having to do with transactions will work perfectly in this environment. That's what it's built for. The problem, however, starts when you have a event store that runs into millions of events. And that has to do with the way those events are stored within a relational database, because a relational database, first of all, is a generic database. It means it needs to support as well storing, adding data, as well as changing data, as well as deleting data. It needs to support multiple tables because we have a relational database. It needs to support multiple indexes per table. If we want to search within that table, we need to create those indexes. And this is going to hurt us over time because we need to take care of the housekeeping of the storage within the database and also the housekeeping of the indexes. And what you'll see is that the performance will degrade over time. As the event store is growing bigger, we can keep a smaller percentage of the database in the memory buffer, also because we have to take care of growing indexes. Then, of course, we have no mechanism to provide rapid access to recent events. You could use something like adding another index to do this. Some index forms will allow you to optimize for recent events, but this, again, just adds to the problem of having to take care of yet another index. And those indexes, generally something like B trees, will become more and more expensive. So a relational database, yes, it's well-established technology, it's available everywhere, and it will provide any functionality that we need, but we have scalability problems. Also, if you want to do streaming from a relational database, that is generally something that has been added later on. So it's not something that is built into the database from its design. So unfortunately, again, we have problems with our requirements. Now, this is why at Axonic we built Axon Server. Axon Server is providing an event store which is going to fulfill all of this. And we did that by building it from scratch in Java. It is purpose-built and designed for event sourcing. It manages files directly. There is no database to do the actual storage of the data. And it uses the open interface based on gRPC that we already discussed. Axon Server is append only by design. And I already mentioned this several times, but it's important to realize we're only adding data. And this means that if you compare that with what happens with a relational database, then Axon Server will show here a straight line because the amount of time it takes to add a record does not have such an impact by the size of the data we already have stored. Axon Server does this by splitting the event stream into segments. And when a segment fills up, it will start a new one. And these smaller segments allow us to very efficiently search on aggregate ID and sequence number. They can be mapped into memory, and to know which segment we need to start, we can use a much simpler index, which is outside of our segments. Then, of course, Axon Server also is made to be searched. The segments are made to be searched backwards in time. Recent segments are then kept in memory, as I already said, which again improves the performance of searching there. Then Axon Server also provides support for ad hoc queries. This can be done using the UI or using the REST API. In this case, here in this example from the Axon Server UI, it's just a simple query on an aggregate identifier, but there is a pretty complex query language that you can use. If you're interested in that, take a look at the reference guide. It has an overview of the language that you can use for this querying. Now, of course, it's nice that we say this, but it's always even nicer if there's somebody who goes and actually checks whether the performance is as good as we say it is. And this was done at a company called Digital Frontiers. There was a shootout between MongoDB, PostgreSQL, and Axon Server using different sizings of servers. And if we start with PostgreSQL, what we see is that indeed, as the size of the event store grows, performance degrades. And we're really talking here about millions of events. So this is a really very large event store. Now, PostgreSQL does allow you to do some optimizations. What you could do, for example, is delay the actual writing to disk, allowing you to be more efficient in your usage of memory caching. Of course, it does introduce a risk because you no longer have the guarantee that the data is always written immediately to disk, but it can help. And in this case, we see that even though the performance increases, we still get the same degrading performance over time as the event store grows. Then the first alternative that we're now going to add is MongoDB. MongoDB is a lot more efficient with these amounts of data than PostgreSQL. Side note that on a local install, MongoDB was comparable, but generally nowadays what you would use is a remote machine. You're not going to have your event store on the same machine as you're running your application. Then if we add Axon Server, we see this, and that is the flat line that we predicted. So, I mean, of course, we were very happy with these results. There are some other findings here. One of them was that the management of the storage for the event store was a lot better with Axon Server. Axon Server actually used less disk space for the events themselves and for the index. This, of course, is not something you can entirely hold against Postgres, because it has to take into account that you might want to change the data. It has to reserve space for that. This generally leads to a lot more wastage of space if you would know in advance that that's never going to happen. Unfortunately, of course, it will happen with the indexes. And you see that on both the event storage and the index usage, actually, Axon Server is a lot more efficient. Other findings, if you are going to use multi-threading in your processing of those events, then you'll see that the performance for PostgreSQL as an event store will increase, but Axon Server does this immediately out of the box. So the performance is good even if you use less threads. Then Axon Server made much better use of the available performance of the server. If we look at performance compared to the different sizes, then Axon Server was the winner in all situations. And also Axon Server was a lot better in doing caching. So if we have a local installation with a local event store, Axon Server is faster. If we do it with a mounted volume, we see that actually it is a huge difference. So if you're interested in the full report, then we have a PDF of this presentation available. I can post that to the Slack channel if you want. Let us know, and we'll give you a copy. Now, when we have our Axon Server instance and we have our applications, we start looking at something which are the bounded contexts. Now, if you're from a background that you already have experience with domain-driven design, a question. If one wants to have a unique index in an aggregate, is there a way to implement user-defined unique indexes in the event store on Axon Server? But aggregate IDs already, you already can use UUIDs for that. So why would you then still need to have a user-defined unique index? I think we'll pick this up later in the Slack channel, if you don't mind. Yeah. Or you want to add, I think then what you're looking at actually is using the data, which means that you're going to look at a view model. So then you would build a view model and have that view model indexed on email address. The aggregate state itself is stored only just to be able to validate that you can execute the commands. It is not used to query on. So the event store is not a generic data store that you're going to try to optimize multiple queries. The problem is, if you want to use an event store for that, what if you have large data structures of multiple aggregates that are related to each other, and then want to be able to have a indexed view on top of that, which goes through different aggregates, combines them so you can efficiently query that. I mean, that is the problem that you get with using a relational database. That is where you first go and normalize your data model and then denormalize it on a few fields to be able to optimize querying. The event store is not meant for querying. That's what you use the view models for. Yes. So then why would being eventually consistent be a problem? I think this maybe becomes a rather large and long discussion that we can better take offline, if you don't mind. Okay. For those who were not looking at the chat box, there were some additional questions about adding alternative indexes for querying and the problem of having an eventually consistent view model. So let's now continue with introducing bounded context. Why would we have multiple contexts? This has to do with the problem that our application will grow and change shape. This is something we already discussed. The application will get multiple components, but it might also be that we have added components to our application. And what you then see is that the actual domain grows together with the application. And as the application becomes larger and more complex, the coverage of that domain becomes a larger domain in the modeling of that domain. Then you get areas within that large domain that has local concerns, but because it's still one domain, those local concerns might contaminate other areas and influence things you do in other areas. So what you see in effect is that you have a domain with subdomains, and you want to keep those separate. So this is why we need to put boundaries around them, and that means we need to introduce the concept of a bounded context. A bounded context is a context or subcontext that we want to have an explicit boundary around. So within that bounded context, we can keep the model consistent, and we will not be distracted or confused by issues outside. So if we take a look at our application, next to implementing that application, we also define our application's language through messages. And if we have those different boundaries, then we're going to get boundaries also in that language, and want to make sure that the messages are also kept within those boundaries. So what we can do is have multiple contexts. We can start by using separate event stores per bounded context, and then keep our messages separate also within those bounds. And then, of course, the question is, does this mean we need to deploy multiple copies of Axon Server? And this is why Axon Server Enterprise Edition directly supports multiple contexts. So whether we have a single instance or a cluster of multiple instances, Axon Server Enterprise Edition will allow you to have multiple fully separate contexts. You're able to configure the security, so access to those contexts per context for individual applications as well as users. And if you have a larger cluster where the cluster instances are distributed regionally, then you can also distribute your contexts onto specific instances. This is something that we're going to look at tomorrow when we're going to talk about clusters. Then, of course, you can have applications that connect to multiple contexts, and use those to build so-called anti-corruption layers. These subjects, of course, are discussed quite a lot in our other trainings concerning Axon Framework and DDD. So please do take a look at the Academy if you want to take a look at those trainings. So given that we have Axon Server, now we need to connect our application. And that means we need to look at these areas within our model. Those are the client applications, and they need to be connected to Axon Server. How do we do that? Of course, in this situation, without Axon Server, we need to make sure that we have the libraries added to our application, and then need specific configurations for the applications, need to make sure that the Axon Framework configuration API is used to do this correctly, or use Spring Boot to do this, and then configure running and maintaining all those solutions. We were not going to do that. We're going to use Axon Server for that. And then it becomes quite easy. So just in your Axon Framework-based application, create a default configuration, build it, and by default, it will use Axon Server. If you use Spring Boot, then you can just add the Axon Spring Boot starter component, and it will do it automatically for you. Then to connect your application to Axon Server, all that is left is actually run Axon Server. If you've read some of the blogs, then you know that this is a subject that I like to talk about. So let's take a look at how to run Axon Server. I've called this 3 roads to happiness. There are basically 3 different ways you can do this. The first is the I have the power way. You locally put the jar file there. You make sure you have a JDK. Please use one of the long-time support versions. Our current default is JDK 11, but we also we build it with JDK 11 starting with Axon Server 4.6, and but we also run it with JDK 17. You can download it from the developer portal, or going straight to this URL, and then you'll get the jars for the Axon Framework and Axon Server Standard Edition. And if you go to this GitHub repository, there are lots of examples on how to run Axon Server and configure it. Of course, you can do it a bit easier by using Docker. Axon Server is on Docker Hub. We have both an image for Standard Edition as well as for Enterprise Edition. There will be tags, of course, specified after this. For Axon Server Standard Edition, there is a latest tag. It is not used by Axon Server Enterprise Edition, so be careful there, but you can add after this -dev, and that one will exist also with latest. The reason is that the Standard Edition latest is kept there because some people are used to this deployment model. We will try in the future to stop running it as root in root and having an Intel-only image. That's not just for the people with MacBooks, but we'd like to have a multi-platform as our standard. The dev images are built using a standard Eclipse project-based JDK image. The only thing is it has bash aboard, which means we added the -dev. It's not entirely a problem. There are enough hardened images that still have bash on board, And in some situations, it's really very useful to have that if you want to take a look on your in your container. There might also be a mentioning of the JDK. As said, number 11 is our default, but the JDK 8 and JDK 17 versions are also available. Or you could have non-root added at the end, in which case Axon Server is not running as root, but is running as the user Axon Server. Be careful there if you're running that locally on a desktop or laptop, because it might cause trouble with the ownership of files for the volumes. This is generally the image that you would use if you're going to use Kubernetes or OpenShift or those kind of platforms. I've added some examples, but take a look on the website of Docker Hub, and then you can see what we have available. Of course, there is an even easier way, which is simply not to have it running on your laptop or your desktop and use Axonic Cloud. If you go to cloud.axonic.io, you can register there, create an account for yourself, and then create your own workspace, and then within that workspace, multiple contexts. Developer contexts are actually free. They have a limited lifespan. They will be deleted after 14 days. So that is a very worry-free way to create a context where you can do some experimenting or demoing. Or you can create a long-living context on a single node, which is not free, or you could get a multi-zone context, or even get a private cluster where the contexts will be on VMs that are reserved for you. Of course, that has a obvious higher price tag. Then you register your app and register it with a specific context or group of contexts, and then the console will present you with your Axon Server connector settings, and you run your application locally and it will work. So let's go and demo that. Okay, I hope this is readable. I know this is not possibly optimal in contrast. Let's do it like this. That is a little bit better. What I have here is a directory containing the content of the zip file, the link for which you had when you registered for the training. I updated actually that zip file, so you may want to download it again. I updated it, I think, last week to include Axon Server 4.6.1. If you take a look within that zip file, there is a PDF file with some example exercises that you can do. We're not going to go do them online, but you can run them. There is a booking app and an inventory app from our hotel demo that you can use. They are referred to within this PDF file. And they're the jar files for Axon Server Standard Edition and Enterprise Edition. Let's start with Axon Server Standard Edition. So if we look at Axon Server, oh, sorry. Take a look here. There are 3 jar files here: the Axon Server Standard Edition jar, a copy of the Axon Server CLI, the command line interface, which allows you to send commands to the REST API, and a small quick tester, which is a small Axon framework application that can send a command, handle that command, and then send an event and handle that event. There are also example scripts. I'm using Bash here with Windows Subsystem for Linux, so I can run those scripts. But let's start with just from the command line java -jar and then Axon Server.jar. What you'll now see is that Axon Server is starting up. Here you see it announces itself with its version, and this doesn't run very fast. The main reason for that is that I am using Windows Subsystem for Linux on a Windows drive. This is a known problem because it's mounted like a network drive. So that performs a bit less than having it fully local. So let's wait here. And what we're waiting for is this message. As soon as you see the message saying started Axon Server, then Axon Server is up and running. And now let's open a browser and go to the first screen. This is the Axon Server UI. You see it's complaining that SSL is not configured and authentication is not configured. We're going to solve that tomorrow. It gives some basic configuration name. In this case, we haven't provided it with any settings, and by default, it takes the host name from the machine it's running on and the node name, the name for this instance of Axon Server from the host name. It uses the default ports for the HTTP port 8024 and the gRPC port for Axon Framework applications 8124. Here in the middle, we have the status of the event store. There's only one event store in Standard Edition, and it has nothing in it at the moment. So the last event is -1, there is none. And if we have very active applications, then we can see some statistics here about the number of commands, queries, and events and snapshots coming in per second. Of course, license is mentioned here, Standard Edition, and at the bottom right, you see which version of Axon Server you're running. And if a new version has been released, then that will be shown here at the bottom. You will be getting an attention grabber here saying that you can update to a new version. Also, there is this information button. If you click that, you get an overview of all the open source libraries that have been used building Axon Server. Axon Server Standard Edition itself, by the way, is also open source. Then if we go to the second tab, the overview tab, here you see a graphic view on Axon Server, and if there are any applications running, they will be shown here above this. Let's run that quick tester. It's in this directory as well. That doesn't really matter. So let's start it like this. I'm using a Spring profile named Axon Server. So the quick tester is not going to use a local event store and bus, but is going to connect to Axon Server. That is typical behavior of this quick tester because normally the default is to use Axon Server. Now, if I start it, you will see the application starting up in the back and it will connect. Sorry. This is the remainder of an old run. That is the problem if you do a lot of demos. And now we see the application connecting to Axon Server here. And it now has sent an event. So if we go to the next tab, which is the search tab, we can search and you see that it shows this event. If we click on that event, we get all the details. What you see here is the token or the global sequence number, which is 0 because it's the first event in the event store. We get an event identifier, a unique ID. We have no aggregate identifier and sequence number and aggregate type because this event is not a domain event. That is simply the way the quick tester works. We have here the Java class name for the event. There is no revision number, so this is a versionless test event. And here we have the serialized data. This is serialized into JSON. You could also use XML. Then here we have a timestamp for the event and no metadata. We'll see some metadata later on. The next tab that we have here is the Commands tab. If we have an application running, and let me start the quick tester again, you will see that the command handler for the quick tester is shown here, and it has this one command handled. The quick tester has no query handlers, so there's nothing shown in the queries tab. The users tab we're going to look at tomorrow. The last tab that we can see here in the UI is plugins, and that's something we're going to show later on. So here, application is gone again, but we now have, of course, 2 events in the event store. Let's stop this and go to Axon Server Enterprise Edition. Let's first stop Axon Server. Okay. Now we go to the other directory for running Axon Server Enterprise Edition. This has a lot more files. Here what you see is that we have 3 directories, node 1 to 3. This allows you to run a cluster of 3 nodes. There are again a number of demo scripts and of course 3 jar files. The only difference with the other directory is that now the Axon Server jar file is Axon Server Enterprise Edition. I added the license file. This license file is in the Slack channel, so if you go and look there, you can download this one. It's valid until 2.5 weeks from now. And then on the script side, what you see is that we have a startup and a startup cluster, and we see for all these there is a normal one and a cluster one. The difference is if you use the simple form of the script, you need to add the name of the node. If you use the cluster version, it will do it for all 3. Let's start up just node 1. If I now take a look at what's happening in the log file, this looks very comparable to what happened with Axon Server Standard Edition. Now it sees here the license and has loaded that. That is a difference. But we're still going to wait here for this message started Axon Server Enterprise. Here you see mention of an extra port, port 8224. This one is used for communication between the Axon Server nodes within a cluster. And Axon Server stops. Now let's take a look at the UI. It looks very comparable to what we had before, but we now have a third complaint. Not only is it complaining about lack of SSL and authentication configurations, it's also complaining that this node is not an admin node. What is happening here? Well, if you're going to use Axon Server in a cluster, and you start an Axon Server instance for the first time, that instance does not know whether or not it's going to be the first node in a new cluster or whether it needs to join an existing cluster. So what has happened is that Axon Server has just started and then said, okay, tell me what to do. So what we now need to do is tell it that we want to start a new cluster. So we're going to do that using the CLI. And going to send it the init cluster command. If I now go here and take a look in the overview, what you see is that first it creates an admin context and then a default context. Those are shown here in this, and it adds an event store for default. Ignore the error. That's a difference between a 200 and a 202 HTTP reply, and it's going to be fixed with the next patch release of Axon Server. If I now want to add a second node to this, I can go and do a startup of node 2. I'm not going to go in what's happening here in the logging. We'll talk about that tomorrow because it has everything to do with how Axon Server works in a cluster. So let's start up node 2. Again, we need to check the logging because we need to know when it has finished starting up. Okay, it's finished starting up. And now instead of sending an init cluster, because then we would have 2 instances of Axon Server, both with completely separate cluster structures, we need to tell this new node that it needs to register itself with the existing cluster. We're running both of them on the same laptop, my laptop. So they're using different ports. The second node is using port 8025. So I have to give it the REST API URL for that. And I need to tell it that it needs to register itself on localhost. I don't need to give it the port because the default 8224 will connect it to the first node. Give the command and then take a look what's happening here. And you see the node has been added to the cluster, and it's also been added to the admin and default contexts. Tomorrow we're going to get all the details about how this works and what's happening underneath. Again, I can also run the quick tester. And if I do that, it will work just as before. We see the quick tester showing up, connecting. In this case, it's connecting to node 1, and it's using the default context. This is, of course, now explicit. with Axon Server Standard Edition, there is only one context, and for compatibility's sake, that is called default. If I go to the search tab, I can now search the default context and we'll see that same message in here, event in here. Just like with Standard Edition, go through the other points of information that we can see here. We have a status. The status of the event store is now per context. So if we have multiple contexts, then you will have multiple contexts in this drop-down box. You can choose which one you want to see the last event token of, and you want to see the statistics of. The license here, of course, is now an Enterprise Edition license. It's valid until the 14th of August. And I can use these buttons to upload a new one. And at the bottom, we see a list of nodes within this cluster. In this case, we have two nodes, one using port 8024 and the other 8025. And for client applications, 8124 and 8125. And for connecting within the cluster to other Axon Server nodes, 8224 and 8225. Tomorrow, we're going to have a look at how to configure this with your client application. Let's continue through the tabs. Of course, the commands and queries tabs are the same. We have a new tab here, apps. This allows you to register applications with specific contexts. And within those contexts, it can get a specific role. This can be used to limit the rights applications have. Of course, at this moment, we don't have access control switched on, and we'll see how that works tomorrow. Again, we have a users tab. Also, we'll show that in action tomorrow. Then for Axon Server Enterprise Edition, new is that we have a tab for contexts, because we can have multiple contexts. I could make a new context here. Let's call it contexts, just to have a bit of fun, and add it to the default replication group. Tomorrow we'll talk about what a replication group is and why you would want to have multiple of those. And you see there are some options here. Again, those are the options I referred to when I talked about indexes on the event store. Then there is yet another tab, which is the replication group tab. This is something we definitely are going to discuss tomorrow, so I'm not going to go into that today. The last tab, again, is the plugins tab. And unless we have questions, we're now going to talk about running Axon Server without running Axon Server, which is, of course, by using Axonic Cloud. So let's close that. We're going to shut down all our nodes. If you go to cloud.axonic.io, you will be greeted here with this console. You can log in using a Google account, any Google account, or any GitHub account. In this case, for the demonstration, I'm going to log in with my private Google account, and you see that it already has that cached. Now, here I have workspaces. I'm going to add a new workspace. Let's call that the Axon Server training workspace. And within that Axon Server training workspace, I can now create a context. There are no contexts in here. So let's create a quick tester context. We want this context on the shared cluster because that allows us to use the development context, which is free. And we can choose where this can be hosted. And we're going to put it in Belgium. Then for the developer context, which is free, it has a 14-day data retention. This means that after 14 days, the developer context will be deleted. It will still show up in the list, and you can easily recreate it, but the data will be gone. So let's create that context. Here you see it shown. I have the option here to delete it. If it has been deleted automatically, I can recreate it. But now what we want to do is register our quick tester. So let's add an application binding. And we want this with our quick tester context. If I do this, I'm presented here with a set of properties that I can use for my application. And let's copy those and go back here. And now I can make use of the fact that Spring Boot that has been used to create the quick tester allows you to create a config directory. And within that config directory, I can now put a file named application.properties. And we'll also add the Spring profile. So we don't need to specify that on the command line anymore. And this is our file. If we now run the quick tester like this, it will automatically pick up all these properties and make a connection to Axon Server in the cloud. Let's take a look. Here you see it started to make an initial connection to Axon Server in the cloud on this port, and then was redirected to the Europe West 1 server in Brussels, connected there, opened the instruction streams, and then registered a handler for the command, then handled the command and handled the event, just like it did when locally. If I go to the console, I can now take a look at my quick tester context and there search for events. And just like before locally, I now have this event here in the Axonic Cloud. Any questions about Axonic Cloud? If not, let's go back to the slides. And let's talk about plugins. Because unfortunately, sometimes you do really want to have a bit of extra functionality that you don't want in your client application. And the most typical example for this is not very nicely put, Upcaster Hell. It's not something you will run into immediately, but if you are a long-time user of the Axon framework, you will notice that sometimes you do need to make new versions of events. You get more fields, or you may have to change fields, and then you get revisions. Axon framework does support this, and what it does add to help in this is something called an upcaster. This means that if in the event store it encounters an event which is for an older revision than the revision handled by a particular handler, then it will apply those upcasters to convert the event to the correct revision. But if we have a large application, a lot of applications with a lot of upcasters at a certain moment, the problem becomes that we need to keep copying those and keep adding them as dependencies to any new application that we want, which is not nice. And the idea is then to put those converters and upcasters in Axon Server as a plugin. Axon Server will then apply this plugin to the configured message types and will do the work before your app gets the result. Another example, for example, if I have an external event bus. What if I already have an event bus that I'm using and other applications need to receive events from my local Axon Framework application? Then what you get is that every time you send an event or an event that needs to be copied locally, you need to send that event again to the external bus. And that is an even bigger problem if it's part of a transaction. Then you need to send that event twice. And this is also a typical thing that you could let a plugin do. We actually have an example application for that. There is an example plugin on GitHub that you can use, and it will show you how to do this, I think, with RabbitMQ as an example. The Axon Server plugin API allows you to write interceptors for commands, queries. It allows you to influence flow control and do things with subscription queries, of course, for events and for snapshots. And it will get them both going in and going back. So for queries and commands, that means the reply, the responses. But for events, that means it will be intercepted before it's stored in the event store. So you can even do things like encryption to make sure that it's encrypted in the event store. And then when it comes back, you can decrypt it if you don't want to handle that in the Axon Framework application, for example, with the data protection module. If you want to develop your own plugins, they are supported both by Axon Server Standard Edition and Enterprise Edition, and they are deployed as OSGI bundles. The API is publicly available on GitHub from this repository, and you deploy them to Axon Server using either the CLI or the UI. So let's have a small demo of that. I have a very naughty implementation for that, a encryption plugin which uses ROT13. If you know ROT13, it's a very insecure algorithm. It just rotates letters 13 positions to the right in the alphabet, but it demonstrates the principle quite well. So let's go and start Axon Server. Let me see. I think we already shut down the cluster, right? Yes. So let's go to Standard Edition. And start Axon Server again. We'll go to the same directory here. Wait for Axon Server to start up. And go to the UI. Remember, we just ran Axon Server We already have 2 events in there. We can use those. Let's take a search here. You see 2 of them. Please note no metadata in them. That will become important later on. And now we go to the plugin page, and we're going to upload this ROT13 plugin. This is a plugin. The sources of this plugin have been included in the Running Axon Server repository on GitHub. So if you take a look there, you can take a look at this plugin. And after we've uploaded it, we can activate it. If you do this for Axon Server Enterprise Edition, you need to specify in which context you want it to be active. Now, if we go back to the search page and do the search again, you will notice that now we have metadata. A metadata field named intercepted has been added. And this shows that before this list was presented in the UI, the event has been intercepted. It's using a Boolean expression result, and the data viewer doesn't know about this type, so it's not using it. It doesn't show, but the value, of course, is true. And if we now go to our quick tester, and run the quick tester, and I'm going to give it a shorter delay so we don't have to wait too long before we can run it again. Like this. We go to the overview. Here we see the application. Now, if I take a look here, and you see that the quick tester is aware of the plugin because it has seen the metadata value. So now it says that all these events, so all the events that ended up at the event handler have been intercepted. If I go and take a look again on the search screen, you will see all of them are here. And even the newest event that has been added is just as readable as the other ones. We get the same message, quick tester application.getItRunner says, hi there. But we now have 2 metadata values. There's also the ROT13 encrypted metadata value, and it also has a Boolean value. And if you would be able to parse this, then you would see that it's actually set to true. I can run it again. It would just add another one, but I'm not seeing this. So to be able to see what has happened, let's go to the plugins tab and disable the plugin. Now, if I go to the search tab and do the search again, you see I have 2 events here that are normally readable and 2 which are encrypted. And you see that even though the newest 2 events have the metadata showing that they were intercepted and encrypted, none of them are now showing the intercepted value in the metadata. So the plugin is not working and is not helping us decrypt the data. That is the demo of plugins. Questions about plugins? If not, let's continue. We're almost there, so don't be afraid. Last bit is about installing Axon Server. And if you're going to install Axon Server, and especially if you want to do that in the cloud, then of course you want to automate that as much as possible. So you need to take a look at how to install Axon Server. It's distributed as an executable jar. So all you need underneath it is an operating system with a JDK. Then you can use a basic set of properties that are always the same, especially if you're going to use Axon Server Enterprise Edition. There will be a number of properties that are always the same, and you can store those in a file named Axon Server.properties in the same directory as the jar file. These properties can also be used to configure the persistent data locations for the event store. So they can link to mounted volumes that are outside of the current machine, typically a VM or a container. Then you can have the startup script retrieve server-specific settings and store those, just like I did for the example with running in Axonic Cloud, using a directory called config and put a file named axonserver.properties in there. Of course, if you're using Kubernetes, then you don't need to build this file, but you can put them in a config map or put them in a secret. And the goal, of course, is to have as little as possible handwork left. This means that when you want to do restore an installation to working order, you could just delete the VM with the operating system disk, or delete the container and replace it with a fresh one. All the persistent data is then on another volume. It will be mounted again and it should get picked up again. Naturally, you can also use this for upgrades. So my advice is, if this is the way you have to go, then please do go for immutable infrastructure all the way. Set up a DevOps pipeline to build your image based on the operating system, Java version, and Axon Server. Make sure that this pipeline is triggered when you have updates on any of those. If you need to set up certificates, make sure you have triggers for those too. Add an automated canary test just to check whether this new image will work. Add an automated upgrade test, of course. Deploy an older version, replace it with the newer, and see if that all works automatically. Then you can also do, of course, a failing upgrade test, because if you'll do an upgrade and you want to do that automatically, you want to make sure that you catch the situation where, for some reason, it failed because, for example, there was a change in either Java or the operating system that turned out to be incompatible with Axon Server. Then you can add a push to production stage because you've tested everything that you might want to test, which means that if everything succeeds, you have a new image that you can just as well immediately put into production. Throw the switch, sit back and enjoy. And this is, I think, nowadays the new normal that we want to strive for, but unfortunately it's not always still the situation that is being used. So, any questions left for today? Because if nobody has any questions, of course, you can also put them in the Slack channel. Then, again, let me refer you to our developer portal, the Discuss forums, the Academy, the GitHub repositories, and the reference guide. Please take a look. And you have a license file. You can download Axon Server and do some experimenting. Tomorrow we're going to build clusters. We're going to do funny things with clusters, like breaking them down and see how they survive that. If they survive that, and how you can rebuild them. And we're going to look at things like security and observability. So if there's no questions left, then that's the end of the session of today. And I hope to see you tomorrow.
See you tomorrow. Thank you. Thank you. It was pretty clear. Thanks.
No.
Thank you.
Welcome.
Thank you. See you tomorrow.
Okay.
Thank you. Bye.
Bye.